Hello, I am Abdurrahman Abdulhamid, Senior Researcher at Samsung AI Center, Toronto. I'm presenting our method on extracting, vignetting, and grain filter effects from photos. Most smartphones support the use of real-time camera filters to impart visual effects on captured images. Currently, such filters come pre-installed on device or need to be downloaded and installed before use. Recent work proposed to extract a camera filter directly from an example photo that has already had a filter applied. Previous work focused only on the color and tonal aspects of the underlying filter. In this work, we introduce a method to extract two spatially varying effects commonly used by on-device camera filters, namely image vignetting and image grain. For image vignetting, we start from an input image that may possibly contain a vignetting effect. We downsample it to 128 by 128 pixels and compute radial intensity bands. Then we concatenate the radial intensity bands to the image and then feed both inputs to a neural network. The neural network is trained to predict the vignetting strength in the input image, which is used to generate a vignetting filter that looks visually similar to the one that exists in the input image. Then we multiply the generated filter by the input content image to reproduce the vignetting effect. To train our neural network for vignetting strength classification, we use synthetic images. We use 2D Gaussian filters to simulate different vignetting strength. For image grain, we start from an input image that may possibly contain some grain effect. We divide the image into small patches, then feed the patches to a neural network that is trained to predict grain intensity. Given the estimated grain intensity and an input content image, we generate a grain layer that we can add back to the input content image to reproduce the grain effect. To train our grain intensity classifier, we use synthetic grainy images generated using simplex noise. On synthetic test images, our vignetting strength classifier achieves 92% average accuracy, and our grain intensity classifier achieves 95% average accuracy. These are some visual results. Our method can faithfully extract and transfer the vignetting effect from input vignetted images to other content images. Similarly, our method can faithfully extract and transfer the grain effect from input grainy images and transfer it to other content images. Here we compare our method to existing style transfer methods. While style transfer methods are more flexible in manipulating image colors and structures, they are not suitable for spatially varying effects, such as vignetting and grain, whereas our method is designed to faithfully transfer such effects. Here we apply joint transfer of all effects of vignetting, grain, and color. We use our method for extracting and transferring grain and vignetting effects, while we transfer colors using the traditional method by Reinhardt. We also tested our method on web images. Our method can faithfully estimate and transfer vignetting and grain effects. In terms of efficiency, our method is extremely efficient, requiring under 100 milliseconds on GPU, compared to other methods that require at least a few hundred milliseconds. On smartphone devices, our method runs within 1 second for initial filter extraction and within 2 milliseconds for filter application. You can try our method out in the My Filters camera feature on Samsung devices such as the Galaxy phones. Thank you.